Okay, let's look at this guy. So this is a line of charge where the point P that we're looking at when we want to know the electric field is not collinear. So it's, in this case, this is on a perpendicular bisector, but at the end of this, I'll also mention what happens if it's not the bisector, but it's still like a perpendicular line to it. I'm sure there's a fancy word for that. All right. So, first step is we need to find a little chunk DQ. There's a little chunk DQ, and we look at point P. And we said, what does that little chunk give for a DE? And it looks like that, right? And let's draw our R. There we go. And let's also assume that point P is a distance A away, right? A away, okay. So when we write DE is K dq over R squared, which is where we sort of are always going. We're kind of looking, all right, okay, this R, we're probably going to want to relate, like when we're thinking integration, right, I'm kind of looking at this, it's going to be X, right? And you kind of, in the back of your mind, you're thinking you're probably going to want to integrate, right, along a dx from negative L over 2 to L over 2. So hopefully you see that's sort of where we're going. So that's going to be our X. All right. So what else? So there's my DE. I always want to look to see what my other DQs give me so that I can see if I need to worry about a component or something. So let's look at this DQ, and then you'll see that DE, yeah, okay. So I'm going to have things that look like this and things that look like that. And so what I'm really going to get are all my E sub y's. So we probably need to sketch out this triangle up here. Maybe I'll switch out of yellow. Maybe that's hard to read. So let's think. Okay, here's R, here's A, here's X. And my E sub y, right? When we do this, DE y, it's DE. Let's see, where do we want to define our theta? How about there? Does that make good sense? So then it's DE cosine theta. Okay. So in that case, when we look at our triangle, cosine theta is adjacent over hypotenuse, and so there it is. So it's A over R. Well, you're also looking at this triangle, of course, and seeing that R is A squared plus X squared square root, right? All right, let's do this. So EY K dq over R squared times A over R, okay? So we get a K and then an A, those are constants, and then we get 1 over R cubed dq, all right? So I'm going to keep going. I'm going to write Ka. So what are we doing here? Our big goal here clearly is to get things into dx. So hopefully you are used to enough looking at, right, a little dx of a thing that has a linear density lambda, and that you know that dq is lambda dx. So we're going to write lambda dx up here. And then what about r? Well, r is this hypotenuse, and we recognized that it was a squared plus x squared, square root of that, but here it's cubed. So we're going to write 3/2. So here we are, K, A, lambda. And I should put my limits here, negative L over 2 to L over 2. And it's dx over a squared plus x squared 3/2. I'm gonna put a box around that because guess what I can't do by myself is that integral. You need to do it numerically. So if this was actually happening on a test, they might just be asking you to set up an integral, okay? Because there's a lot of understanding that goes into setting up the integral. And remember, this is a physics test. This is not supposed to be a calculus test. And so, they're not going to ask you to actually put something into your calculator and numerically solve something. But they very well could ask you to set up something like that. The other thing that they can actually ask you to do is if the line is not on the perpendicular bisector, so they might ask you something like that. So what would happen here? Well, a little bit of dq over here, right, would give you something here. The dq's over here would give you something here, but you would get more of that kind of stuff, right? There's more charge over here, giving you things up and to the left than over here, which is giving you things up and to the right. So your dE would still be the same. You'd still do your k dq over r squared, but okay, I'll redraw this. So here, something like this, you would now have, right, your resultant would be like that, right? Because you would have more stuff coming from the right. So how you would actually do that is you would, we solved the problem before by just saying, oh, let's just look at DEY. Well, now you'll have a DEY and a DEX, right? And your DEX, if this is, that was our theta, then your DEX will be DE sine theta, and your DEY will be DE cosine theta. And remember, it was just A, X, and R, right? And cosine theta was A over R, and sine theta was X over R, right? There was our theta. And so it's not horrible to set those up, but you do have to actually know what you're doing. All right, hopefully that helps.